Welcome back to B.I.A. Firearms. Right now the camera is going to be a little fuzzy. Been working against tornado warnings the majority of this week, so I'm sorry if this is coming out late. But today we are going to talk about ftt122 week 6. I have 1, 2, 3, 4, 5, 6, 7 definitions to tell you, but I'm going to use this pin right here to help demonstrate, because this is an everyday object. I know people have pins. Not everybody has a dummy round to use as an example. The first thing is trajectory and sights. While trajectory is crucial for accurate shooting, it's the curved path a bullet follows, influenced by gravity and air resistance, but our sights help aim, because whenever you fire a bullet, I'm going to use two objects. This right here, as soon as it leaves the barrel, it arcs up and moves back down, while this will be our sight. The sight keeps a true line of sight on whatever we're aiming at, but when the bullet arcs, it's going to hit 2 points. The first line, which is at the beginning, following all the way down to where our target is, where our line of sight and that path will hit again. That is the whole purpose of trajectory and sights, due to the fact that when a bullet is fired, it arcs, and our sight keeps a steady line of sight on it. Next one is a gyroscopic drift. It's a phenomenon when a bullet is fired from a right twist barrel, or any type of twist in barrels. Well, twisting the rifling inside the barrel. It experiences a slight lateral drift to the right during flight, caused by aerodynamic forces to the bullet's spin. So let's say as soon as it fires, it goes off. Well, we're going to go this way if it loads. As soon as it fires, this is my right, and then it'll correct itself again to hit back straight. While drag is a force of air resistance that slows down a bullet as it travels through the air, affecting its trajectory and velocity. Velocity is basically the speed, and trajectory is the outcome where I want to hit. So let's say high wind, and this is moving extremely fast, and boom, hits by the wind. Now it's moving slower and dampens everything. Then we have the Magnus effect. The Magnus effect on a bullet, while present, is generally less significant than other aerodynamic forces like drag. It can still affect the bullet's stability and trajectory, particularly at long ranges like 500 meters, where you would have to aim a little bit higher just to hit that target. Because again, your bullet's going to be unstable for a hot minute, but when it spins, it'll get back into it. The Coriolis and Evos effects, I'm not Eotvus, I can't pronounce that to save my life. I'm not going to even try to butcher it again. This is caused by the Earth's rotation, causing moving objects like your bullet to deflect to the right in the northern hemisphere, or to the left in the southern hemisphere. While the Eotvus effect is a component of the Coriolis, the other effect I am butchering these, causes vertical deflection, which bullets hitting higher when shooting east and hitting low when shooting west. Vertical angle. Vertical angles refer to the angle of the bullet's flight path relative to a horizontal plane. They measure upwards or downwards. The positive angle meaning the higher the target, the higher we aim. So let's say your target's up here, you want to hit him, you line your sights up a little bit higher, and it'll calculate right all the way back to trajectory and sights just to hit that again. While if he's lower on a negative angle, we have aim downwards. Now we have the high ground, basically a Star Wars reference when Obi-Wan looked at Anakin and went, I have the high ground. When we aim a little bit lower just to hit our target down. Now we have transonic ballistic performance. Transonic and ballistic refers to the speed of sound Mach 1, roughly between Mach 0.18, not 0.18, 0.8 and 1.2, where the bullet experiences a turbulent transition and potential instability affecting the accuracy and the ballistic coefficient. So I have a bullet that is not designed to reach transonic, and it somehow reaches it. This lovely guy that's going to go spinning, like a little canting a little bit, is now going off the wall and hitting something else. But I hope this demonstration helps out a lot more, and thanks to the pen and to the dummy round, helps understand it just a little bit better. I suck at giving actual demonstrations, but I hope the demonstrations were good enough and I explained the terms just as well, because I'm trying to keep in mind I'm trying to explain this to a customer versus a professor and an entire class. But thank you for your time, and I'll see you next week.